Okay, so for this problem, you wanted to know how to decide on the window. So basically, once you have your equation plugged in into y1, so I put in x cubed minus 65x squared plus 988x plus 2076, you have to decide where your x, what your x means and what your y means. So the input x means days since June 1st. And then your output y means numbers of birds. So if you just put in the equation and you hit graph, you might see some nonsense. You can't see how the function is because you're not looking in the right spot. You need to look like zoomed out. I want to see the entire function. So you have to decide on the window. So for the window, I need to decide what does x mean. The input x means days since June 1. So it doesn't make sense for days to be negative, so I need to start at a positive value positive value 0. Then, how long am I looking? Well, I'm looking for days, so I want to see the month of June, the month of July, maybe the month of August as well. So I need to look how many days? From day 0 to day 60 or day 90. So we have to try. So let's try 90. So I'm looking for 3 months. And then for the y, well, it doesn't make sense to have negative number of birds. So I'm going to start at 0 birds. And then for y max, well, ultimately I'm interested to see where there are 3,000 birds. So I need to look up to how many birds? Maybe 5,000. So you put in this window and then hit graph. And you can kind of see the function. You see I don't see this bump, so I can furthermore say that y can go to 7,000. I want to see the entire function. 7,000. And then you hit graph. So now I can see the function. So this is how the population of birds change. So on June 1st, they are right here, and then as days go by in June, the population of birds increases to a max right here, and then it goes down, and then it increases again. So we want to know when it's equal to 3,000. So one way to do this, you go into y and you just plot the horizontal line y equals 3,000. And then when you hit graph, it's just gonna take this line, and where it intersects our graph, that's where the population is equal to 3,000. So you notice how I don't have anything after here, so I can actually change my x to not go all the way to 90. It looks like I can change it to go to, I don't know, 60, so that I can see better. So if I change it to 60, just to 2 months, I can see better. That's the whole point of picking the window, is I want to see clearly what my function is doing. So now to find when, so for what x value is the y value 3,000, I just need to find when, for what x this y is here 3,000, and for what x, when, in what month is the population of birds 3,000, and then again for what x, in what month and what day is the population 3,000 again. So we see that it happens in 3 spots. So to find the exact intersection point, you need to calculate. So I'm going to press second trace, that takes me to calculate, and I'm going to pick 5 because I want to calculate the intersection point. So you see how this cursor is blinking right here? Well, I want to tell it that I want to find this intersection point first. So I'm going to move it. So I need to find the intersection between 2 curves. So I'm going to move it and tell it what's my first curve. So my first curve is this polynomial. Let me move it a little up. So my first curve is the polynomial. So once the cursor is blinking in the right spot, enter. And then my second curve, see how it moved on the line, y equals 3000. Second, press enter again, and then press another enter. And then it gives you the intersection point. It happens when x equals 1. So when x equals 1, the y, the population of birds, is 3000. So x equals 1 corresponds to June 1st. That's what's given in the problem. So the bird population equals 3000 on June 1st. And then let's see the next intersection point. So now I'm going to calculate again. So second, calc. I'm going to calculate an intersection point. And now the first curve, I want to look at the second intersection point. All right, so once I'm on the curve above the intersection point, so this is enter, and then you see how it moved on the line, so I can click enter again and then enter again. So now it's going to tell me the second intersection point, which happens when x is 22 and y is 3000. So on June 22nd, the population of birds is 3000 again. And now we need to calculate the third intersection point. So again, second intersect or trace, which takes you to calculate, pick 5, enter, and let's go closer. We'll go closer to the third point now. So I'm gonna go until I have the cursor below my intersection point. So here is good enough. So once I have it there, I click enter, and then it moved on the second curve, which is on the line. So that's good. Click another enter and then another enter. So now this happens for day 42. But day 42, since June has 30 days, day 42 means it's in July 12, right? So the population of birds reaches 3000 again on day 42, which is July 12. We subtract 30 from 42. So this is what you would put in your answer. You would say that the bird population is 3000 on June 1st and June 22nd, and then on July 12. All right, hopefully that was helpful. So for the window, you kind of just think about, what does the input represent? What is the x? Does x go, can it be negative? How far should I look? And it's kind of like guessing a little bit too, because I don't know beforehand how high this function is going to go. So I just kind of zoom out. I need to zoom out so I can see the entire function, not just portions of it. All right.